Jill figured it out. These are the perfect squares. That would be 1 squared. And that would be 2 squared. And 3 squared. And 4 squared, which is a fun game to play. And 5 squared. So the next one would be... Oh, that's very laggy. Let's see why it's laggy. Let's close out a few of my windows. Good job, whoever said all of those. Cool. Haha, this guy. I will be able to write conjectures and disproved conjectures using a little thing called counterexamples. What's a conjecture? Well, conjecture is when you use inductive reasoning to arrive at a conclusion. Basically, the conjecture is the statement that you can make based off of information that you have. So if you look at these examples, if a figure is a kite, then it is a polygon. That is a conjecture. Often it's given as an if-then statement, but it doesn't always have to be. That's called a conditional statement, but it doesn't have to be given to you as a conditional statement. Make sure that you guys are keeping the notes that I send you. I sent them yesterday. This chapter is very, very, very heavy on the vocab. Okay? Here's another conjecture. Any number divided by itself is a whole. So 4 divided by 4 is 1. 3 divided by 3 is 1. Whatever divided by itself is 1. Here's another one. If you look at multiples of 4, 4, 8, 12, 16, 20, all multiples of 4 are even. Okay? If a conjecture is a statement of fact that you can make based off of information that you know. Okay? So when I look at problems like these, I can look at these things and make a conjecture. A conjecture is basically you wording out what's next in the pattern. Okay, so, you know, when you did the warm-up, if you're wondering, why did we do that warm-up? Why did we do a warm-up on patterns? Because we were able to look at our numbers, and Jill was able to look at the numbers and say, those are the perfect squares. So if they are the perfect squares, then the next 3 terms will be blah, blah, and blah. I can write a conjecture, and I'm not going to write the conjecture here, but I can say the cost goes up, as Santiago said, $2.25. Very good. So use that fact. Use that fact that the cost increases by $2.25 to give me the next 3. I'm going to beat you. Now, we're not going to do a whole bunch. Maybe we won't do 2, 3, and 4, but give me the conjecture for 2 at least. Maybe I won't write it out, but give me the conjecture for 2.
$45.
Yeah, you add 45 minutes. So the next ones would be, what, 12:30, 1:15, and then 2. Okay? Let's use words like rotate and the yellow triangle. What appears to be happening in 3?
Rotate the yellow triangle to the right.
Right, clockwise. But yeah, I agree with you. So the next 3 would be the left, and then up, and then the right. 4, it seems like you just add another circle on the outside of the previous circle. 3 is wacky pants. Let's see if you can figure out. I'm sorry, not 3. 5 is wacky pants. Let's see if you can figure out 5, baby. I know it. They are all divisible by 3. That is correct, but that's not going to help me figure out the next 3 terms. Think of adding. I am vibing. I'm vibing to the psychosis music that I have going on in my head. What if you add 3 plus 3? What do you get?
6.
And then what happens if you add 3 plus 6?
9.
So what's the pattern? What's the conjecture that you can make about these problems? But then what 15, bruh? It's not add 3. You add
225.
Huh?
225.
Not 25. Close. If I added 3 plus 3, I got 6. If I added 3 plus 6, I got 9. What?
Add the sum to the next number.
Very good. You add the previous 2 numbers to get the next number. So 9 plus 15 is beep. And what do I do to get the next, or what is the next one?
39.
Uh-huh. And then you add these 2, and what is it? 60.
63.
Very good. I was able to figure out 6. Let's see if you can figure out 6. It involves multiplication and addition. I dropped my pen. It is almost half, my friend. But I want to move from the left to the right, not the right from the left. And almost doesn't cut it. It is not 2.5-ish. You have to multiply what? You multiply something, then you add something.
You multiply 2, add 2.
Good. Multiply 2, add 2. So 2 times 2 is 4 plus 2 is 6. 6 times 2 is 12 plus 4 is plus 2 is 14. 14 times 2 is 28 plus 2 is 30. 30 times 2 is 60 plus 62 is 62. 62 times 2 is 124 plus 2 is 126. And then 254. And then 510. So some of these are not so obvious. Some of them you have to think outside the box, or in this case, outside the circle. Oh, man. Yes. Yes, thank you. Yes. Well, that was conjecture. The product of 2 even numbers. Now, again, if we look at the conjecture, a conjecture is a concluding statement that you can make. Okay, so really when we worded these out, I should have said, if you add another circle around the previous pattern, you get the next pattern. If you add the 2 previous numbers, you get the next number. If you multiply a number by 2 and add 2, you get the next number. If you add $2.25, you get the next number. If you add 45 minutes, you get the next time slot. Now it looks like I just have part 1. So what we're looking at for problem 7 and the rest is this is the first half of it. What statement or what conclusion, and there are several answers, but we'll stick with whatever you guys say that is true. So what can we say about that? So it's basically you started out with this and then you finished the statement. So the product of 2 even numbers, what can you say?
Will be even.
Is even. And so you just completed a conjecture. What can you say about the relationship between A and B if A and B equals 0?
They're both the same number?
You are half right. They're the same number, but one of them is
even.
Oh, no.
Oh.
They're the same number, but one of them would have to be. If they add up to 0, one of them would have to be. Well, if they're the same number, then 5 plus 5 is 10. So how can I change one of those things to make it instead 0? 5 plus what? -5. So if A and B add up to 0, then A and B are the same number, but one of those numbers are what? Negative. So you got to think it's just, you are now leaving the math zone of math and entering the logic and reasoning zone, which is going to be very fun for a few of you, I think. But let's move on, because the next part's a little bit more important. Counterexamples. Counterexamples are what I deal with all the time when I have political fights on my Facebook. Yes, I still use Facebook. And so someone will be like, oh, how could you, I'll make a complaint about a certain politician, and then someone will argue the counterexample, trying to prove me wrong. Or maybe somebody will make a dumb, yes, Santa, yes. Somebody will make a dumb thing about, a specific candidate that they may want to vote for, and then I will fire back with a counterexample. So it's basically, if someone were to be like, let's not use politics. I don't want to get into politics. Let's just say somebody says President Grump is racist. Or I'm sorry. Let's just say my dad said President Grump, and I'm not talking about anybody in particular. President Grump is not racist. I could fire back and say, like, well, then you should look up the Central Park 5, or you should look up how that president wouldn't rent to certain races, or or maybe somebody says President Grump loves women, or President Grump shows respect to everybody. And I could be like, well, President Grump also said negative things about women, and President Grump also said negative things about Mexican people. And I can argue back with a counterexample. President Grump has really helped the economy. And then I can say, well, ever since the coronavirus, there has been a record amount of losing jobs, and he will be the only president in recent history that has lost jobs, whereas all the other ones seem to gain jobs. You see what I'm saying? That's a counterexample. When someone tries to say something, but I prove them wrong. Okay, so this statement, if you live in Texas, then you live in Corpus Christi. And someone could be like, no, I live in Houston. So your statement is false. If the grass is wet, then it rained. Well, no, that could be false, because I could have watered the grass, or maybe it snowed, or maybe I dumped a bucket of water on it. Sprinklers. Yes, Santiago. Yes. All rectangles are squares. And I could be like, well, no, this rectangle is a rectangle. So those are counterexamples. Counterexamples is probably the part of the section that you'll love, because it gives you an opportunity to argue the point and prove somebody wrong. President Grump is going to make Mexico pay for the wall. Well, no, he didn't. By the way, I'm not talking about anybody in particular. Just to let you know. Just making up people, making up situations, making things up. Refer to the table of the number of smartphone users in the United States by year. So we have all of these users in millions. And just looking at the table before even doing anything, it seems to me that as the years go on, the amount of users go up. So I'm going to make a table in part A, and then make a conjecture about smartphone use in 2018. So if I know that I'm going to predict the future, this is what I'm going to do. And Santiago, you're on the right path. What am I doing? 2018. So I have 10, I have 11, 12, 13, 14, 15, 16, 17, 18. So this is the year down here. Okay, I'm making up my own chart. Don't expect perfection. I have my users in millions, so I'll put million. Wow, that looks awful. Users. Let me see. My low number needs to be 62, so I'll put 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. All right, so 2010 is going to be 62 million, so we'll put a dot right there. Boop! 2011 was 93 million, so that's going to be 80, 90, somewhere around there. Boop! 2012 was 122, so what was that? 90, 100, 110, 120, so right around there. Boop! Yes, you make your own graph any way you want. Yes, you make your own graph any way you want. 10, 12, 11, 12, 13. 13 was 145, so boop. 14 was 178, so right around there. Boop. And 15 was 191, so like right around there. Boop. So there's my graph. I'm not going to connect the dots because it's not a straight line. However, whether I look at my graph, that I'm going to admit the graph that I made was pretty poor, because really what I should have done is I should have gone higher so that I can predict. So why don't I do that? This ended up being 200. So 210, 220, 230, 240, 250, 260, 270. I am following this trend, and it's not perfect, but I'm following this trend for the most part. I care about what happens at 2018. So 2018 is right here. So if I go up and hit my line, it looks like I end up with like 250-ish. So I can make a conjecture that, and this is part B, in 2018, oh my gosh, about 250 million what is this? Number of users will have smartphones, or there will be 250 million smartphone users. So I worded that poorly. In 2018, there will be 250 million smartphone users. Did I need a graph to prove that point? No. In fact, I think it was Santiago who was basically saying, I forget exactly. Let me go back to the chat and see the words that he used. It increases by a certain number. And if you're looking at it, it seems to increase by give or take a little bit under 30. Now, does it always increase by a little bit under 30? No. I mean, that goes up 29. Hold on. Let me find my mouse. There it is. That goes up 29. That goes up 29. That goes up 23. That goes up 26. That goes up 20. So it does go up, but not by the same amount. We're just kind of making guesses here. So if on a test, you were going to say, do you mean, Santiago, do you mean 222 and 245? Is that what you meant? Oh. Oh, my bad. I see what you're talking about. Oh, did I say the wrong thing? I may have said the wrong thing. So again, it's just, we're guessing here. So if on the test you said, in 2018, there will be about 240 million smartphone users. That's not wrong. My answer was based off the graph that I made. That's a conjecture. A conjecture is you're using information to say something, whereas I guess I thought this was going to be a counterexample problem. That's probably going to come next. Yes. This is the argument. We are going to come up with a counterexample, a reason to show that each conjecture is false. So if A and B are complementary angles, they share a common side. Complementary angles means they add up to 90 degrees. Can someone give me an example of when two angles that add up to 30 or 90 degrees will not share a common side? I mean, this is an example of two angles that are at 90 degrees that share a common side. Okay. This angle right here has that side in the middle, and this angle here has that side in the middle. Who says I have to keep them together? Who says you have to keep them together? Selena Gomez, that's my answer. If a ray intersects a segment at its midpoint, then the ray is perpendicular to the segment. So here is a segment. There's a segment. I'm going to have a line, or a ray rather, that goes through the middle. How can I draw a red line that goes through that red dot so that it will not create 4 90-degree angles? I mean, I guess I have to draw a line this way, huh? I guess I have to draw a line that way. That's the only way I can do it. I mean, I can't draw the line any other way so that it goes through. I mean, that's the only way that I can draw a line that goes through. Matt, I can't do something like this. Oh, I can do something like that. I can do something like that. So this is me proving this is wrong. I can create a ray that intersects at an angle, which means it won't create perpendicular angles. All right. Okay. That's it. So that went a lot faster than I thought it would. Find a counterexample for this statement. Look at that cat. All cats are orange. Somebody make a counterexample, please. Unmute yourself and give me a counterexample. Okay, Camilla said lies, my kitten is black, and that would be a counterexample. Santi says my neighbor's cat was gray. Oh, uh-oh. Oh, well, is gray, or it's dead.